All right, math nerds, welcome to part 7 of the derivatives series. This crazy math nerd saying hey to all the crazy math nerds that are out there. So in the last video we talked about the chain rule, and you use that when you have functions that are composed. And that means you have a function inside of a function. So I thought I'd wait for this particular example until the second time we started talking about the chain rule, because it is a little bit confusing to some. So the first thing you want to do is I want to see who the outside function is. So I'm going to rewrite this guy so he's easier to see. Anytime you have a trig function that is raised to a power like that, you're going to want to rewrite him and put big parentheses around him so you can really see what's going on. So the most outer thing that is happening is this cube. So in order to find the derivative, slope of the tangent line, instantaneous rate of change, we're going to take the power first. Now notice I'm not going to change anything in the inside. That will stay the same. And then I have to take the derivative of the next inside thing. So the cube is the outside, the cosine is the next inside, and the 9x squared is the other function composed. So there are 3 functions composed here. So there's the first step to do the power rule. The next thing I have to do is take the derivative of cosine, which is negative sine of whatever theta is. So notice I'm going to leave that alone. So that's like step 2. There's step 2. And then you must take the derivative of that inside function, which is 18x. So notice that if we have 3 functions composed, we'll have 3 parts to this rule, to this chain rule. There are 3 parts to the chain because there are 3 functions composed. So a lot of people say, I don't know when to stop. Well, you should, if you have however many functions you have composed inside of each other, that's how many derivatives you should have. Let's talk a little bit about how do we do things, how do we take derivatives when we have what I call tabular data, or just stuff given and I don't even have the function itself. This is Master Math Mentor page 32, I believe, and this is from the classwork of this derivatives that involves the chain rule. So let's take a little look here. Notice that you don't know what the function is. You just know things about the function. You know some values, right? And you know some values of derivatives. And so that's all you know. And so if we're going to find the derivative, let's do number 18. Well, let's do this. Let's talk about 16 and 17. This is the product rule, so I'd have to do the product rule to do this one. This is the quotient rule. How do I know that? Because it's a division of 2 functions of x. This is going to require a chain rule, and this is going to require a chain rule because you have a function inside of a function, right? The f of x is inside the cube, and the g of x is inside of the f of x. So to do these, what you really do is you write them out symbolically and then plug in your information. So if I'm trying to find the derivative of this, then I have to do 1 d2 plus 2 d1. And it doesn't matter how you do those. Remember, when you do the product, it's always one function and the other guy's derivative plus product plus the other guy and the other guy's derivative. And so then you're going to plug in, it says at x equals 2, so you plug 2 in there. So f of 2, g prime at 2, plus g at 2, and then f prime of 2. Now you see where all these values, and you just plug them in wherever they go. F of 2 is negative 3, so I'm going to put a negative 3 right there. G prime of 2, let's see, G prime of 2 is negative 2. Okay, and then G of 2 is 3, put that right there. And F prime of 2 is 6. And then negative 3 times negative 2 is 6. And 3 times 6 is 18, and that would be 24. So in order to do that, you just write out the rule and plug in the numbers, okay? I want to show you the product one, and you can do the quotient one if you want to, but I want to go to the chain. So in order to take this derivative, you have to apply the most outside thing, which is the cube. So it's going to be 3 times, leave the function alone, squared times the derivative of the inside. Now notice that I'm doing all of this symbolically. And then I plug the value that they tell me, the 2, in. So 3f of 2 squared f prime at 2, and then you just plug your values in. So you have to write it out symbolically, plug your value of x in, and then figure out what your value is. F of 2 is negative 3, and f prime of 2 is 6. And so then you multiply those together, and negative 3 squared is 9 times 3 is 27 times 6, whatever that is. And you can multiply that. In this chain, we're going to do the derivative of the outside, leave the inside alone, times the derivative of the inside. And notice I did that symbolically. And then I have to plug in the 2. Oh, now I know why we have this extra little guy right here. So f prime at g of 2 must be equal to g of 2 is 3. Yeah, that's why we had to have that extra f prime of 3. I was wondering where that was going to come into play. And it just did. And so f prime of 3 is 4, and g prime at 2 is negative 2, and that's negative 8. Okay, so if you're given, now there are some really crazy ones that are in your homework. Let's see if I can get this guy to go down. And it's just like huge table. See that big table? So you just have to be careful to go find the right person. And with a table like this, you have more values you can play with. And so again, you're just going to do the derivative of each one here. You can do the product rule, the quotient rule. The quotient rule, again, there's just different numerators and denominators. Have to apply the chain, change that to a negative 1 and apply the chain to that. And so, and these are really good problems. If I were to write an AP test, I would have problems like this on the AP test, where there was it's called tabular data, where that just means you have data in a table. I know, crazy. And in this table, you will find all the parts that you need. And remember, this is at x equals 3. So have fun with your homework tonight. That'll be a lot of fun. So 2 things. Oh, there's another one. Look at that. There's fractions in there. Oh, my. So remember, let's go back to my little show here. So let's go back. And so there's 2 things. One thing is that if you have information about a function and don't actually have it, you have to symbolically find the derivative, plug in the value, and evaluate using the values that they give you. If you have some kind of trig function raised to a power like that, you're going to want to rewrite it like this first, and then as many things as you have composed, which we have a 9x squared in for the theta of cosine in a cube. So if there are 3 things composed, you will have 3 parts to your derivative. And just make sure that you take this power, if there's ever a power there in a trig function, and write it on the outside, and you can see who is the most outside and who to do first. So I hope that's been fun, and hope you've had fun in derivatives part 7. The next thing we'll talk about will be piecewise functions. Bye to now.